Hi everybody. So today we're going to be looking at some problems that deal with trends in categorical data. And this first problem says the following. Calculate the following percentages based on the frequency table. Round to the nearest hundredth of a percent. So I copied this over to Miro, so I'm just going to look at it from Miro. Okay. So we're going to calculate each percentage to the nearest hundredths. Okay. Now, first one is percentage of acoustic guitars that needed neck repair. So, get out my pen and make it a little bit thicker. Okay, good. So, what's the percentage of acoustic guitars that needed neck repair? So, the first thing we have to do is look at the acoustic guitars. Okay, and here we have our acoustic guitars. And of these acoustic guitars, what percentage of them that needed neck repair? So, we're looking for this number. This is a frequency table. So they're asking us really for the relative frequency of the acoustic guitars that need neck repair. So out of a total of 131, because we're reading down, right, for acoustic. So out of a total of 131 guitars, 41 of them needed neck repair. So that would be 41 over 131, correct? And so if we calculate that in percentages, that's going to be roughly 31.30. Okay, so again, hundreds, it's going to be 31.30%. Okay, so that would be our first answer here, 31.30%. And the next one says percentage of all guitars that were acoustic and did not need neck repair. Percentage of all guitars. So now we have to look at all guitars. So out of all the guitars, this is our overall total, correct? That's the overall total. Overall. So out of all of the guitars that were acoustic and did not need neck repair. So how many were acoustic which didn't need neck repairs? So only 41 needed neck repairs. So 60 plus 30, 90 did not need neck repairs. So 90 did not need neck repairs, right? So if we're looking at percentage of all guitars, acoustic and electric combined, so only 90 that were acoustic and didn't need the neck repairs would be the 60, this 60, and the 30, correct? Out of an overall 262. And that comes out to roughly 34.35%. Okay, 34.35%. Okay, so that would be your 34.35%. Okay, and then finally, percentage of electric guitars. So here we have our electric. Okay, so we're looking at the electric. Percentage of electric guitars that had a broken string or needed body repair. Okay, remember, or in set notation, in set theory means union, correct? Union, which means you have to add these two up, right? So or means union. So electric guitars that had broken strings, so this, or needed body repair here. Okay, so we have, so 48 plus 34, that gives us 82. So 82 guitars, you add these two up, out of 131. And that comes out to 82 divided by 131 is roughly 62.60. 62.60%. Okay? So that is our final answer, 62.60%. Okay. Okay, so just to save some time, I paused the video and I plugged in the numbers, and we're going to check right now, and they are correct. Okay. All right, let's go to the next problem. Okay, so in this problem, we have Jake, and it says Jake just learned to identify the difference between an oak tree and a maple tree. He was curious about the concentration of these trees in his neighborhood, so he went out and identified several trees that were either by the pond or in the field. Unfortunately, he smudged his data tables and can't read some of the values. The absolute and relative frequency tables below show Jake's salvage data. Can you help him figure out the rest? Okay, so again, Jake he had his data, he wrote it down, but it got smudged. So this is what he has here. That's what he was able to salvage. And using the relative frequency two-way table, we're going to try to see if we can reproduce the frequency table, the two-way frequency table that he originally had. So I'm going to pause the video. I'm going to copy this over, and then we'll continue the problem so we can save some time. Okay, so I tried pausing the video, but then you get this big square with arrows in the middle covering the table, so I guess I'm not going to pause the video. I'll just try to do this as quickly as I can. All right, let's get a new board out. Okay, now I'm going to copy this table. Actually, I'm going to copy both of these tables. Okay, we'll try to reproduce them together. Okay, I'm going to copy it over here. Okay, and I think we're ready to go. All right, put it on this side, and then we'll leave some space for the work, to do some work. All right, so let's begin. So the first thing, remember, this relative frequency table, again, remember when it says row percents, we only read across by row. When it says column percents, then we're reading by column. Those cells that have column percents in them, and of course totals are the totals. All right, so let's begin here. We have the numbers for the oak, right? We have all the figures for the oak, and we have figures for the pond. What we're missing are the figures for the maple trees in the field and the column total, and also the field and column total for the rows and the columns. Okay, so these totals here. All right, so let's begin. Let's go here. It says let's look down. We can look down from maple. So if we're looking at the column totals for maple, use green. Okay, it says here there's 44 maple trees in the pond, which represents, so the maples, which is represented by, that's 46.32%. Okay, so 44 maple trees in the pond represents 46.32% of all maples. Okay, now, excuse me, which means in the field, okay, the maples that are in the field represents 53.68%. Okay, and so if you add these up, you get the 100% here for the column. So let's try to work it out. So I'm going to say 46.32% of all maples is equal to 44. So if I want to know what the total maples are, then I just do 44 divided by 46.32% or 0.4632, right? And then that's going to give me a figure. Let's work that out. 44 divided by 0.4632. And that gives me approximately 94.99. So let's round that to 95. So we should have a total of 95 maples. Well, now we can actually put the 95 in here, right? Which means we could just do a little subtraction to figure out how many maples are in the field. So 95 minus 44 is of course equal to 51. So it looks like this is going to be 51 here, correct? And now we can add across to get our row totals. So 40 plus 51 gives me 91. Okay. And then you can add across for the row totals for these two numbers. So let's find the overall total. So 70 plus 95, it looks like that's going to be 165 total. Okay. Now, here they're asking you find x. What is x here? They're asking you what is the x here? Well, the way we do that is, of course, we have to find these are row totals, these are column totals, which doesn't make sense. So now we're looking at the total number of trees in the pond. X represents total trees in the pond, or near the pond, I should say, near the pond, right? There are no trees in the pond. Okay. And here it's saying that, okay, so if we have 55.15% of all trees are in the field, correct? Then how many trees do we have in the pond? Well, we have the total number of trees now, correct? So let's figure it out. If there's 55.15 in the field, and if we subtract that from 100, so 100 minus 55.15, correct? Then that's going to give us 44.85%, right? 44.85%. So 44.85% of all trees are going to be near the pond. All right, so let's go back. I'm going to pause this, and then I'm going to put all the numbers in, and then we'll check, all right? Okay, so I have filled in all of the values from our work on the previous page, and now let's take a look, and they are correct. Okay? All right, take care, guys.